In this video, we're going to continue our introduction of the rules of differentiation. We already have introduced you to the power rule, the product rule. Today, we will do the final two rules, which are referred to as the quotient rule and the chain rule. So I'm going to start out with the quotient rule. Quotient rule, obviously by name, is used for differentiating quotients. Quotients are things that are divided. Typically, we'll see them in fraction form like this. And this is the rule here, how it works. So if you're doing a quotient, we'll often refer to them as numerator and denominator. I have it written out here in words below, but I'll just, so rather than f of x, g of x, you'll hear me often talk about numerator and denominator. So f of x would be our numerator, and g of x would be our denominator. If you look at this, f prime of x means the derivative of the numerator. So it's the derivative of the numerator. You then multiply that by the denominator, g of x, subtract the original numerator, multiply that by the derivative of the denominator, and then everything gets divided by the denominator squared. All right, so as I said in the product rule, I recommend you say these as you're doing them. So here it is, kind of put in words. Derivative of the numerator multiplied by the derivative of the, derivative of the numerator multiplied by the denominator minus the numerator multiplied by the derivative of the denominator. Everything divided by the denominator squared. All right, so this is quotient rule. So I'll show you how this works. So like the product rule, you just have to make sure you get that memorized so you know the pattern. So I look at this one and I see a quotient. So to do the derivative of a quotient, I'm going to use the quotient rule. Quotient rule says, I'll color code it for us here. Take the derivative of the numerator, so I'll put that in blue. Derivative of the numerator would be 3x squared, take away 14x. So the rules that we've talked about it in our prior videos, we have to make sure we can recall those. Here's derivative of the numerator. Multiply that by the denominator. Subtract the numerator. And you multiply that by the derivative of the denominator. 8x to the 7th, subtract 20x to the 4th. And then you just put everything that you just did over the denominator squared. Okay, so let me just refresh what I just did here. So I did derivative of the numerator multiplied by the denominator. So if you're trying to see what this means with that original notation, this would be like your f of x. This would be like your g of x. So this is f prime of x, derivative of the numerator, multiplied by the denominator. Subtract the numerator, multiplied by the derivative of the denominator being g of x, and then everything is over the denominator squared. Right? That is how the quotient rule works. So again, it's just a pattern that you have to get familiar with. Doing practice examples of it is obviously the way to get that ingrained in your mind so that you'll have the rules down. I got a few more examples that we'll look at. Let's look at this one here. So it's quotient. I need to use the quotient rule. F prime means derivative, so f prime of x would be derivative of the numerator.
Miss Prince, people in the office, please.
Multiplied by the denominator. Subtract the numerator. Now multiply that by the derivative of the denominator, which would just be the number 3. Everything divided by the denominator squared. And for what we're doing right now, we're not going to simplify these at all. We're just going to leave them like this. We're not going to expand anything out. We're not going to try and cancel anything. Just leave it like it is, just so that if we're trying to look at your understanding of the pattern, we can see where there may be issues that you're having. Okay. All right, let's have a look at this one. This one's a little bit more difficult because the numerator has 2 factors. Right? This bracket is multiplied by this bracket. Now, you could expand it out. However, I'm not going to do that because they may get more complicated later where you couldn't expand them out and you'd have to be able to deal with having a product in the numerator. So what this is going to require is us to use the product rule within the quotient rule. All right, so here I go. F prime of x. Derivative of the numerator. So just pretend the numerator is a question on its own. This would then fall under the examples we did in our last video. It's a product. So product rule is derivative of the first multiplied by the second plus the first multiplied by derivative of the second, which would be 9x squared. So all of this is derivative of the numerator. Notice I put a big square bracket around it. So I group that. There's derivative of the numerator. Multiply that by the denominator. Instead of cube root x, I'm just going to write it as x to the 1/3. Same thing. Subtract the numerator. Multiplied by, I'm in a room here, so I'm just going to put multiplied by, put a little arrow. So technically this will go up here, but I don't have room. The derivative of the denominator, which would be negative 12x to the 5th plus 1/3 x. Subtract 1 from 1/3, you'll get negative 2/3. Okay, derivative of the numerator, which was a product rule, multiplied by the denominator. Subtract the numerator, multiplied by the derivative of the denominator, and then all of this would be divided by the denominator squared. So we'll have to say, do I have to put x to the 1/3 there, or can I leave it as cube root x? It doesn't matter, they're equivalent. So you can write it this way, or you can put cube root x. They mean the same thing. Okay, so there's some examples of the quotient rule. Last rule in the base rules of differentiation is referred to as the chain rule. Now the notation here can sometimes be a little confusing. It's basically when it's functions inserted inside of functions, composition functions. And the way you do it is you take the derivative of the base function, and then you multiply it by the derivative of the function that it was inserted inside of that. Now that, with this notation, that can look a little confusing. It's actually quite easy when you look at an example. Here's an example down here. This is an example of the base function was x to the 10th, and we submitted the function 5x cubed plus 1 inside of that function. So to do the chain rule, I'm going to kind of deviate from that notation and just explain it a little bit differently now. Chain rule is essentially used when you've got something in a bracket raised to an exponent. That's when you use the chain rule. And the way the chain rule works is this. It's almost like power rule to start. You multiply by the exponent, leave this untouched. So it's just 5x cubed plus 1. So the biggest mistake students make is they want to put the derivative in here. It doesn't go in here. It goes, you'll see in a second, it comes afterwards. So I multiply by the 10, leave this as it is. I take one off, just as if it was x to the 10th. So now it's 10, this to the 9th, and then beside this, you multiply by the derivative of what's inside the brackets. 15 x squared. So if you look up here, that's the last part of your chain rule. That's your f prime of x. So that's the derivative of what's inside the bracket. All right, so multiply by the exponent, leave the function as is, just subtract 1 off the exponent, and then beside it, multiply by the derivative of what's just between the brackets. And that's referred to as the chain rule. All right, so let's scroll down here. I've got, it's way down here. This one, if I look at it, leave that one for a second. Let's do these two first. We'll go back to that one. So if I look at this one, say, well, how do I know it's a chain rule? I know it's a chain rule because it's 5 minus 3x to the fourth. Now, students, we have there's no bracket.
Just a notification.
So in here, this really means 5 subtract 3x to the fourth raised to the exponent 1/3. That's what this means. So it's a function inside of brackets raised to an exponent. So these, anytime you have a radical, you need to make sure you're thinking of it in this terms, and then you can apply your power rule, or sorry, your chain rule. H prime of x is equal to multiply by the exponent, leave between the brackets untouched, subtract 1 off that exponent, so 1/3 minus 1, which is 3/3, will give me negative 2/3, and then multiply by the derivative of what's in between these brackets. Negative 12x to the third. There's the chain rule. Okay, so then what you have to make sure you realize is now all of your other rules are still in play. So when I look at this one, for example, yep, look, there's a chain rule. Something in brackets to the 6th power. But in front of that is another function. So this is a function multiplied by another function. That's a product rule. And then as I'm doing the product rule and I do derivative of the second, I'm going to have to use a chain rule. So I'm going to have to use the chain rule as I'm doing the product rule. This is what it would look like. So it's a product, derivative of the first. Multiply that by the second. Plus the first. Multiply that by the derivative of the second. The second is a chain rule. So I'll just do a chain rule. So imagine you're just differentiating this. Multiply by the exponent. Leave the function as it is. Subtract 1 off your exponent. Multiply by the derivative of what's inside the brackets. Okay, let's just jump back to that one that I skipped. Now that we kind of get a better sense, hopefully, of how this chain rule works, let's have a look at why I skipped over this one. Well, this one, the problem is there are 2 chain rules. Right? There's this to the 8th, this to the 20th. But if you look at the big picture, it is a quotient. It's 2 functions divided, which is going to require us to use the quotient rule. As we're doing the quotient rule, when we say derivative of the numerator, then we'll look at this and say, hey, wait a second, the numerator, that's a function in brackets to the 8th, that's chain rule. So I'm going to have to use chain rules as I'm doing the quotient rule. This is what it would look like. G prime of x would be, so derivative of the numerator, chain rule. 8, leave your function as it is, take 1 off the exponent. Multiply by the derivative of what's inside the brackets. This is derivative of the numerator. Multiply that by the denominator. Subtract the numerator. Now multiply that by the derivative of the denominator, which would be another chain rule. Multiply by the exponent. 1 minus x to the minus 7th. Take 1 off the exponent. And now differentiating these brackets. So constant is 0. This would be 7x to the minus 8. Derivative of the numerator multiplied by the denominator. Subtract the numerator multiplied by the derivative of the denominator. Last part of chain or quotient rule. Everything divided by the denominator squared. Well, if it's 20 and we're going to square it, that's going to turn it to 40. You multiply exponents when you raise exponents to other exponents. Okay, so we now have all the rules of differentiation identified. We have our power rule, which you can see used extensively as you're doing all these other rules. We have a product rule, we have a quotient rule, and we have a chain rule. So it's at this point where we have to now try and make ourselves comfortable with these rules. So let's suppose I just had these 4 questions. Well, if I look at the first one, I'm going to do them in a moment, and you might want to pause the video and try them yourself here, because at this point it's just a mix and mash of the rules. So when I look at these, this is a bunch of terms all added, subtracted with powers of x. This is just a bunch of power rules. This one, however, if I look at it, is this bracket multiplied by this bracket. This is going to be a product rule. This one is a function divided by another function. This one I would use the quotient rule. And then in this one, I notice there's a bracket raised to an exponent here. So this one's going to be a chain rule. All right, so let's do each of those. So I said you can try them on your own now if you like, and then just watch my solutions after to see how you make out with them. I'm going to put the solutions to each of these up now. So the first one, y prime would be. I'm going to rewrite it. So that's, sorry, let me back up here. It's not y prime. I'm just going to call it y equals. So I'm going to leave that one. It's already good. Instead of 5 over x squared, I'm going to write it as 5x to the minus 2. Instead of square root of x, I'm going to put x to the half, 3x to the 3/5, and pi to the 4 is no big deal. That's just a constant. Now I'm ready to do y prime. So y prime would be multiply and take one off the exponent. So 9x squared. Negative 2 times negative 5 plus 10, x to the minus 3 plus 1/2, x to the minus half, minus 9/5, x to negative 2/5. Derivative of a constant is 0. Finished. Okay, so that one just used power rule repeatedly. Next one is a product. So I've got my first factor and my second factor. So f prime of x would be derivative of the first. So remember, 8 root x is 8x to the half. So that's going to be 4x to the negative half. Take away 5x to the fourth. There's derivative of the first. Multiply that by the second. Plus the first. And then that gets multiplied by the derivative of the second. So constant, which is 0. Negative 5 times negative 1 is 5. Take one off your exponent. There we have product rule. Example 3. We said that this one is a quotient. So it's a function of t. Again, the variable doesn't really matter. Still done the same way. So h prime of t would be derivative of the numerator. 42 t to the 5th minus 12 t cubed. Now this means cube root of t to the 7th is t to the 7/3. So the derivative of that would be 7/3 t, take away 1, which is 3 over 3. That's going to give me 4/3. That's derivative of the numerator. Multiply that by the denominator. Subtract the numerator. Multiply that by the derivative of the denominator, which would just be the number 8. Everything is then divided by the denominator squared. That's an example of quotient rule. Of course, as we're doing these quotient rules and product rules and chain rules, we're using power rule extensively. So that's kind of like your main rule to make sure you're good at. I'm sure by this point, most of you've got that one figured out. And finally, I've got a function inside a bracket raised to an exponent on the outside. That is chain rule. Chain rule is as follows. Multiply by the exponent, leave in between the brackets as is, subtract 1 from your exponent, then take the derivative of what's inside the brackets. This time I'm going to put a bracket here because I've got a couple of terms. So the derivative of x to the 5th is 5x to the 4th minus, now look what we run into. This is in brackets to the 7th power. It's a chain rule. So I'm going to have to use a chain rule as I'm doing the chain rule. So now the derivative of this part is 7, 2x plus 8. Leave it, remember, you leave this as it is. You take one off the exponent, and then you take the derivative of what's inside that bracket. Okay, so let's just restep that one. Multiplied by the exponent, left this as it was, and took one off the exponent. Then you go inside the brackets in here, and you start taking the derivative. Well, x to the 5th is just power rule, so 5x to the 4th. Minus, then you run into, from here to here, something in brackets to an exponent, chain rule. 7, leave the function as it is, take one off, multiply by your derivative in the brackets, which was a 2. Okay, so that one had a chain rule used within a chain rule. Now I got one more example. This is an example that will require me to use all of the rules in one question. And you say, well, how do you, why? Why would I need all the rules? Well, it's a quotient, so I'm definitely going to need the quotient rule. When I go to do derivative of the numerator, I have a product, so that's product rule. And when I go to do derivative of the denominator, it's chain rule, and of course it's power rules everywhere you're doing your derivatives inside these brackets. So all of your rules of differentiation will get used at once. Let's see if we can manage this one. And again, you may want to pause and try it on your own first, and then see how you make out with the answer. All right, here is the answer. Derivative of the numerator. So this is going to require me to use product rule. Derivative of the first, 24x squared minus 3, multiplied by the second, plus the first, multiplied by derivative of the second. All right, so all of that is derivative of the numerator. So in quotient rule, you do derivative of the numerator, which required me to use the product rule in this case. Then you multiply it by the denominator. So we rewrite the denominator, 5x squared plus 1 to the 6th, minus the numerator. I'm running out of room here, so let's go down here. So minus the numerator, which is 8x cubed, take away 3x plus 1, multiplied by x to the 5th plus 2x to the minus 4. So there's the numerator. And that gets multiplied by the derivative of the denominator. Well, the denominator is a chain rule. It's a function in brackets to an exponent. So it's 6, 5x squared plus 1 to the 5. Right, leave the function, take one off the exponent, and now you need the derivative inside the brackets, which would be 10x. All right, let's retrace my steps. Derivative of the numerator, multiplied by the denominator, subtract the numerator, multiplied by the derivative of the denominator. Now, of course, if I had room, all of this would be sitting over here, and then I'd put one big line. So all of this would be divided by the denominator squared. So it's already to the 6th. So when you square something to the 6th, it's going to end up to the 12th. There you have it. So that uses all rules of differentiation in one question. Power rule, product rule, quotient rule, chain rule, all used together. In your class notebooks, you will find a practice question on just quotient rules, and then there's another practice question or practice set of questions on chain rule. And then we'll finish up with a a video on our rules of differentiation. It's not a video, an assignment with our rules of differentiation a little bit later on in the week. Okay, reach out if you have any questions, and best of luck.